Welcome you all to Alpha and Omega Mathematics by Vijaya Jackson. Let us see the topic coset of a group. Coset. The meaning of coset is common set. Common set between two sets. So it is called coset. Coset is common elements between two sets of a group. So the definition of a coset says coset. The definition says, let capital H comma star be a subgroup of G comma star. So for defining coset, we need a group G comma star under the binary operation star, and also we need a subgroup from capital G. We have two types of cosets. So one is the left coset, another one is right coset. The left coset we define like this. The left coset of capital H is defined by small a into capital H is equal to AH such that A belongs to capital G, H belongs to capital H. So this way we are defining left coset of a given group capital G. So see here, just to take it one element from capital G and another element from capital H. So taking a element from a group capital G, small h belongs to capital H. So you are defining the left coset of the group. So here the elements from capital G lies in the left side. The elements from capital G lies in the left side. Therefore, we say that it is coset, left coset of capital H into capital H. Here, the left coset having elements are in the form A into H. So such that A belongs to G, H belongs to capital H. So the same way we can define it right coset. So right coset H into A. So A belongs to capital G. So the element from capital G lies in the right side. We can say that it is a right coset. So this is equal to set of all the elements are in the form H into A such that A belongs to G, H belongs to capital H. So this way we are defining coset of a group capital G. So let us do problem based on coset. The first question is, consider a group capital G equal to 1 comma minus 1 comma I comma minus I. This is well known set. The subset from capital G, capital H is equal to 1 comma minus 1. It is a subgroup. It is a subgroup of capital G. So then find left coset and right coset of H in G. This is the question. The question is, so one G group is given, G equal to 1 comma minus 1 comma I comma minus Y group is given. From G, so we have one subgroup. The subgroup is H is equal to 1 comma minus 1. So we are finding now left coset and right coset. So first to find out a left coset. So given G is equal to 1 comma minus 1 comma I comma minus I. Capital H is equal to 1 comma minus 1. Now to find the left coset, left coset. So each element of G we are calculating the coset. So each element from capital G. So the first element of G, just to take it, the first element from capital G, it is 1. So therefore I am taking 1 multiply with the subgroup capital H. So 1 into H. So take one element from G and multiply it with the set capital H. So this is equal to 1 into 1 comma minus 1. That is the meaning. So H subgroup is 1 comma minus 1. So multiply it 1 with each element of the set. So 1 into 1 is 1. So 1 into minus 1, again minus 1. So our answer is now 1 comma minus 1. So 1 into H answer is 1 comma minus 1. The same way, take the second element from capital G. So it is minus 1. So again multiply it with the subgroup capital H. So this is equal to minus 1 into the subgroup H is 1 comma minus 1. So multiply it, minus 1 into 1 is, it is minus 1. Minus 1 into minus 1, it is 1. So again minus 1 into H, we have got the answer is the set minus 1 comma 1. Now take the third element from capital G. So what is third element? The third element is I. So I dot H, I into H. So multiplying I with H set. So this is equal to I into H set is 1 comma minus 1. So multiply it now. So multiplication is I into 1, it is I into minus 1 minus I. So our set I into H is equal to I comma minus I. The fourth element from capital G, it is minus I. So again we are multiplying minus I with capital H subgroup. So our answer is minus I into 1 comma minus 1. It is multiplied now minus I into 1. So this is minus I. Minus I into minus 1, it is plus I. So the answer is minus I comma I. Now we are going to check these four answers. So here, so 1 into H when we calculated, no? So that way we have got the answer is 1 comma minus 1. Minus 1 into H also we have got the answer is minus 1 comma 1. So from this, combining these two, we can write it 1 into H is equal to minus 1 into H. You can write it like that. Both the sets are same. The sets are same elements. Again see here, I into H minus I into H. I into H minus I into H. So you have got the set answer. So check the elements of the set. Here I comma minus I comma I. Here also both the answers are same. Therefore, we can write it I into H is equal to minus I into H. So you have got two left cosets here. So one left coset is 1 into H is equal to minus 1 into H. The second left coset is I into H is equal to minus I into H. Therefore, the conclusion is now left cosets are 1 into H is equal to minus 1 into H. I into H is equal to minus I into H. So similarly, we can find the right cosets also. So right cosets, so how will you calculate it? To find right coset. So here G set is 1 comma minus 1 comma I comma minus I, the same set. We are calculating right coset. Capital H, it is given 1 comma minus 1. So for finding right coset, so taking an element from capital G and write it in the right side. So therefore H into 1. We are writing here 1 is from capital G, write it in the right side. So this is equal to H set as 1 comma minus 1 into 1. So multiplying 1 with H, so the answer is 1 comma minus 1. So again take the second element from capital G. So it is H into minus 1. So again see here, multiply it 1 comma minus 1 with minus 1. The answer is now minus 1 comma 1. Similarly, third element. So I, H into I. So this is equal to, so 1 comma minus 1 into I. So the answer is now 1 into I, it is I, minus 1 into I, it is minus I. So again, the last element from capital G is minus I. So therefore, multiplying with H minus I equal to 1 comma minus 1 into minus I. So our answer is now, see here, minus I, here minus I plus I. So again combine it. Check all these four answers. By checking all these answers, we can conclude it now. So right cosets are, so 1 into h into 1 equal to h into minus 1. The next right coset is h into I equal to h into minus I. There are two right cosets we have got for the given subgroup capital H. So here, so h into 1 is equal to h into minus 1. H into I equal to h into minus I. So again, right coset, it is also again a coset, set only. So right coset is also, it is a set containing elements. So again, see here, one way the cosets are equal, otherwise it is disjoint, it is a different set. So this is actually one theorem. So this way we are finding right cosets and left cosets of a subgroup of capital G. So let us see the next question. The next is let capital G is equal to 1 comma a square comma a power 3. So suppose a power 4 exceed a power 3, put it to 1 and recycle it. B, a group and the subgroup capital H is equal to 1 comma a square is a subgroup under multiplication find, question is find all the cosets of H in G. So cosets, so you have to find both right cosets and left cosets. Okay, so just write it out. What is the given group? The given group is G is equal to 1 comma a square comma a cube. Suppose here it is given a power 4 equal to 1 means, so when we multiply it, sometimes we get exceed a power 3. So exceeding a power 3, a power 4 comes, put it to 1. A power 5 comes, again a power 6 comes, a square. So again rotate it. Then H is given 1 comma a square. So first to find out left cosets. To find a left coset, so for finding left coset, so take an element from capital G and write it and put it, the element of G is in the left side. So 1 into H, 1 into H. So answer is 1 into H is 1 comma a square, 1 comma a square. Multiply it, 1 into 1, the answer is 1. 1 into a square, it is a square. So the next element from capital G is A. So multiply it A with H. So A into 1 comma A square. So now the answer is A into 1. This is A. A into A square. It is A power 3. So the third element is A square into H. So this is equal to A square into H is 1 comma A square. So this is equal to, multiply it, A square into 1. It is A square. Again it is A power 4. So see here, look at this, A power 4 getting, but our set is 1 to A power 3. So just A power 4 comes, put it by. So this is A square comma 1 only. So since A power 4 is equal to 1. Since A power 4 equal to 1. So now the last element from capital G is A power 3. So multiply it with H, A power 3. So A power 3 into 1 comma A square. So this becomes, after taking multiplication, answer is A power 3 comma A power 5. So A power 5 is, we can put it by, this is A power 3 comma A. So now write the left coset, conclude it. So left cosets are, So first set, see here the first set 1 into h answer is 1 comma a square. Again the third set a square into h. So it is also a square comma 1. The both these two sets are same elements. So therefore 1 into h is equal to a square into h. This is one left coset. Another left cosets, the remaining two sets are the second set and fourth set. The second set is a dot h. This is a comma a power 3 elements. Again a power 3 dot h. This is the set containing the elements are a power 3 comma a. So both are same. So therefore here we can conclude it a dot h is equal to a cube dot h. So these are the left cosets of the given subgroup. So again, find out our right cosets. To find right cosets, so again checking procedure is same, but writing the G element in the right side. Okay. So here taking the first element, it is 1. So multiply it h into 1. Multiplying h into 1. So this is equal to h set is 1 comma a square dot 1. 1 comma a square dot 1. So our answer is 1 comma a square. Again, second element h dot a. So 1 comma a square dot a. So multiply it a comma a power 3. Then h into a square. So this is equal to 1 comma a square into a square. So here also 1 comma a power 4. A square comma a power 4. So this becomes a square comma 1. A power 4 comes, put it, it is 1. So again, so this is equal to h dot a power 3. So this is 1 comma a square dot a power 3. Answer is a power 3 comma a power 5. So now the answer is a power 3 comma a. Okay. So we have multiplied, we have got the answers. Cosets we have found. So finally conclude it. Conclusion, what is the conclusion? So right cosets are so here the first and third, here also first and third sets having common elements, same elements. Therefore h dot 1 is equal to h dot a square. Again second and fourth set is same, common elements it has. So h dot a equal to h dot a power 3. So we have got two left cosets and two right cosets in the given groups. So this way we are finding, cosets, left cosets and right cosets for the given subgroup of G.